AI is starving. We've scraped the internet, but it's not enough. Experts warn we're hitting the AI data wall, where high-quality human data simply runs out. Human annotated data is too scarce and expensive for the scale we need. If we don't solve this bottleneck, AI progress stalls. But there's a shift, the move towards synthetic data. Meet Simula, a revolutionary reasoning-first framework. We'll explore the Simula pipeline and its dual-critic system that ensures synthetic data is actually smarter than the original. Is synthetic data the key to reaching AGI or a digital echo chamber? By the end of this video, you'll see how Simula is rewriting the rules. Let's dive in.
Welcome to The Explainer. Today, we're tackling a massive problem facing modern artificial intelligence and a really revolutionary reasoning-first solution called Simula. Look, if you've been paying any attention to the AI space, you already know that data is the fuel powering everything we're building right now. But what happens when that fuel tank actually starts running on empty?
It's a pretty high-stakes reality we have to face. The abundance of highly diverse internet data is quite literally running dry. We've scraped the web, we've ingested the books, the articles, the code, the whole shebang. And sure, while that's given us incredible generalist models, it makes it incredibly difficult to train specialized AI models. When you need deep, targeted expertise in niche subjects or privacy-sensitive domains, that internet-scale data just isn't there anymore.
So what's the fix? Well, it's something called synthetic data. Basically, this is artificially generated information acting as a scalable, programmable alternative. Relying on real-world manual data collection is just way too slow and way too expensive at this point. It creates this massive economic barrier that shuts out independent researchers. Plus, relying on real human data makes fixing societal biases this completely intractable black box problem. Think about it. If we can't fully control the inputs, we absolutely cannot control the fairness of the outputs. All right, here is our roadmap for building specialized AI datasets from the ground up. 1. The AI data bottleneck. 2. The synthetic data dilemma. 3. The Simula Framework. 4. Quality and complexity. And finally, 5. The future of AI data. Let's jump in.
Starting off with Section 1, the AI data bottleneck, scarcity in niche domains.
So while those everyday generalist models are super impressive, building a specialized AI for, say, niche medical or legal fields means dealing with very scarce data. And there's a hidden cost to this bottleneck that we don't talk about enough: the danger of reactive AI safety. Our current reliance on real data forces us into this totally reactive approach. We basically have to deploy a model, wait for it to fail on some weird edge case in the real world, and only then do we harden it against that failure. For safety-critical systems, that trial-and-error approach is literally untenable. We need a way to proactively generate those edge cases.
Which brings us to Section 2, the synthetic data dilemma, defining good data.
Okay, so if synthetic data is the answer, the massive challenge becomes defining what good synthetic data actually is. Let's use a fun, relatable example. Say we are generating a specialized dataset of stories about cats. To solve this, we have to balance two things: global diversity and local diversity. Global diversity means mapping all the possible broad categories. We need different cat breeds, different environments, different story formats. But local diversity, that means zooming in on one of those intersections and ensuring we have real variation. If our global map points us to a red cat lying on a couch, local diversity ensures we get hundreds of unique, varied interpretations of that specific scenario, rather than just the exact same phrasing repeated over and over. Moving right along to Section 3, the Simula Framework, reasoning-first pipeline. So how do we guarantee both global and local diversity at scale without it turning into a mess? Enter Simula. It's this incredible reasoning-first pipeline that builds data points completely from first principles. Here's the multi-stage architecture in a nutshell. Step 1 is mapping the space to ensure that global coverage. Step 2 uses agentic refinements to populate that space with complex, locally diverse examples. And Step 3 applies dual-critic filtering to absolutely guarantee the quality of the final output. Let's break these down. Step 1 begins with determining factors. The AI actually starts by building a conceptual map. If we ask it for our dataset of cat stories, it uses reasoning to figure out that, hey, a comprehensive dataset needs core components. It proposes factors like cat type, story format, and intended audience. It's literally setting the boundaries of our universe before it even writes a single word. Next up, it takes those broad factors and generates a taxonomy. It expands them breadth first into this highly detailed hierarchical tree. So it takes a broad concept like domestic cat, breaks it down to short hair, and drills all the way down to a highly specific British short hair. It builds this incredible map for every single factor, giving us a highly structured, totally controllable space to sample from. Now, to actually create the data instructions, the framework samples from those massive taxonomies to create mixes and turns them into what are called metaprompts. But crucially, it understands compatibility. It avoids completely illogical mixes. It knows you probably shouldn't combine a toddler audience with a gory horror novel, right? Instead, it formulates a metaprompt that makes sense, like compose an exciting haiku about a house cat who goes on an adventure. Finally, we enter the generation and critique phase. The creator AI generates the story based on that precise metaprompt. But actually, it doesn't stop there. It immediately enters into a dynamic, back-and-forth editorial dialogue with a critic AI to refine the data point. This ensures it strictly follows the taxonomic rules we just set up. That brings us to Section 4, curating quality and complexity, refining the outputs. Look, generating the data is only half the battle. We have to ensure it's actually accurate and follows the rules. That's where the double-critic step comes in. It acts as a rigorous, totally unforgiving editor. It performs point-blank semantic checks, asking, is there actually a house cat in this text? Is it strictly a haiku? But for factual data sets, it goes even further. It independently verifies if an answer is correct, and then, in a totally separate step, evaluates if it is incorrect. This dual approach is brilliant because it cleverly mitigates AI sycophancy, where an AI might just blindly agree that an answer is correct simply because it generated it.
And we definitely can't forget about complexity. Simula can actually be instructed to explicitly complexify a prompt. Why does this matter? Because generating highly complex data yields massive results. In the research, when testing on the GSM 8K math dataset, training a model on the high complexity split yielded a massive 10% accuracy gain over using low complexity data. Basically, harder synthetic data creates much smarter models.
When we look at the results across multiple, incredibly diverse benchmarks, from cyber threat intelligence to multi-step grade school math, all the way to complex legal exams, using the full Simula system is almost always the dominant strategy. Combining that global taxonomy mapping, the local meta-prompt diversity, and the strict double critiquing consistently beats baseline synthetic generation. It absolutely proves that how you generate the data is just as important as how much you generate. Let's wrap things up with Section 5, the future of AI data, programmable workflow. Ultimately, what Simula gives us isn't just a data set, it's a programmable synthetic workflow that turns the sketchy black box of internet scraping into transparent, reasoned engineering. As the source research explicitly states, synthetic data is primed to play a central role in new AI leaps. By moving beyond the limits of human-generated text, we are completely democratizing AI development. It really leaves us to wonder, what incredible, unbiased, highly specialized models are we going to be able to build now that AI can safely, logically, and creatively generate its own realities? Thanks so much for joining me on this explainer. Keep questioning, keep learning, and I'll see you next time.